I'll mention it again. Since we have such a large call today with so many camps, we're going to have an awesome discussion, but it's important to keep your mic on mute when you're not speaking just to reduce the background noise and keep the call quality decent. So how I'll do it, since there's so many camps, I'll sort of go alphabetically to prompt questions from all the camps. We're talking to Dr. Craig Merrett today at the University of Ottawa. He's calling all the way from Ottawa, and apparently it's sunny there today, so that's nice. We'll be talking to him about, since today is flight day at STEM camp, and your activities are making paper airplanes and helicopters using rubber bands and coffee cups. So as you're thinking about questions, you want to think about, questions related to what makes objects fly, lift, drag, stored energy, things that will help you. Oh, I see some paper airplanes there. Is that Ingersoll? Awesome. So I'd like to get started now. I was wondering if there was a question at Dundas that we could kick off. Has Dundas thought of a question that we could kick the call off with?
Okay, we got a question right here. There you go, Rachel.
Why do birds fly?
Did you hear the question?
Why do birds fly? All right. All right. Birds actually fly a little bit differently than airplanes. So the reason why birds fly is as they flap, they're basically pushing air away. So if you've gone swimming and let's say you start pushing the water like this, you'll go forwards. So birds do something similar. They push the air out of the way to go forwards as they're flapping, and it works for them. Airplanes are a little bit different.
Yeah, that's not a bad question to start because I think some of the campers will be making an ornithopter, the flight machine that sort of pumps air like wings. So not a bad question to start with. Maybe Dr. Merritt, before we go any further into the questions, you can introduce, what your research looks at, what's cool about your job, what you do at the University of Ottawa.
All right. Actually, I'm at Carleton University. University of Ottawa is a different institution. So I'm an aerospace engineer. So all my school studies were in how airplanes fly, how do helicopters work, and how do rockets get astronauts up into space. What I do now, I'm a university professor, so I'm a bit like your teachers in school, but I'm also an engineer. So when I'm not teaching class, I'm off doing aircraft design and trying to figure out how aircraft will look 30 years from now. And those aircraft will be a bit like birds, that they can change their wings during flight and hopefully make a more comfortable ride.
Excellent. That sounds like some interesting work and very pertinent to today. So the campers will learn a lot from you today and make some successful airplanes. So I want to get to more questions. Was there a question we could go to in Ingersoll?
What kind of metal are airplanes made out of?
Sorry, can you repeat the question?
Yeah, Ingersoll, you're sort of breaking up. Could you repeat that question again, please?
Um, what are airplanes made out of? What kind of metal?
Oh, what are airplanes made out of?
Yeah, what kind of metal?
What kind of metal? Most modern airplanes are all made out of aluminum. So if you're in your kitchen at home, you probably have aluminum foil for cooking. What we use for airplanes isn't that much different. It's just thicker.
Oh, Dr. Merritt, you might have to repeat your answer. I think so many people on the call, the quality's just dropped a little. So
Okay.
if you could try to say it again, we'll see if it's any better.
All right. So the question had been, what are airplanes made out of? What type of metal? Uh, Most airplanes are made out of aluminum. So if you've been in your parents' kitchen, you probably have a box of aluminum foil that you use for cooking. That's the same metal we use on airplanes.
So aluminum foil is the same sort of metal used on airplanes, just to repeat your answer
Yes.
for Craig. Okay, okay. Good question. Maybe you can incorporate some foil into your paper airplanes in Ingersoll. Now this call seems pretty frozen right now. I don't know if anyone can hear me.
I can hear you,
Goddard,
but
you can hear me, Dr. Merritt?
yes, but all the videos were frozen for a moment there.
Yes, they're still frozen for me as well. Let's try and continue. I'm going to go now.
Well, that's a little better.
Was there a question at Goddard?
Hopefully they joined us.
I could hear somebody before. Was that Goddard? Or who was it?
That was Waterdown.
Waterdown. Okay, let's go to Waterdown. Do you have a question for Dr.
Yeah,
Merritt?
yeah, we've got a question right here.
Okay.
How can this fly?
The video is currently frozen, so could you describe what this is?
It's
What is it? It's
a straw with two circles, a little one and a big one.
So there's a little one at the front and a big one at the back.
Yes, the videos come up.
Oh, okay.
Yes, actually, that will fly. The only thing you have to be careful, and this is true with all airplanes, is weight. Uh, if if your little airplane there is too heavy at the front or the back, then an airplane will just flip end over end. But those wings, the circular wings, will actually work. And in the 1950s, they made a real airplane with wings like that, and it flew.
Okay. I understand now.
Thank you.
Cool. All right. So moving along, just so we can try and get a question from each location during this call, is New Hamburg still on the line? And did you have a question you could ask Dr. Merrett?
We're
in
here.
New Hamburg? Okay.
Ready to ask a question? Okay, say it nice and loud.
How much gas does it take an airplane to get lifted off the ground?
All right, so the question is, how much gas do you need to get an airplane off the ground?
Yes.
I'm going to assume you mean a passenger airplane where a lot of people are on board. So a big airplane. Well, for a passenger airplane to fly from, let's say, Toronto across the Atlantic Ocean, that airplane usually carries about 6 tons of fuel. So you put that in perspective, that's about 3 times the weight of, 6 times the weight of your car, your parents' car. In takeoff, you probably use about 1 ton just to get off the ground.
Wow, it's a lot.
Yeah, wow. I didn't think it would be that much. That's a lot.
It is, and
That
just imagine the fuel bill. If you've ever filled up or been with your parents when you filled up a car and how much it costs on the gas pump, imagine 6 tons of gas, how much that costs an airline.
Yeah. No wonder the plane tickets are so expensive.
Yes.
All right. That's good. I'm gonna try and go back. Is Goddard still with us? STEM Camp in Goddard? Okay. Let's see. Paris? Was there a question for Dr. Merrett at STEM Camp in Paris?
You guys have questions? Okay.
What's the difference between a bird and a how do birds fly?
Could you repeat
I'm
that?
sorry. Yes.
Okay, talk louder.
What's between a bird and a human? How do birds fly and humans can't?
Oh.
Okay. So why do birds fly and humans can't? So I take it if you mean if a person strapped on some wings and started flapping, why can't they take off like a bird? Well, the first thing, birds have hollow bones, whereas humans don't. Our bones are solid. So just our bones alone are much heavier, even though we're a lot bigger. If you took a human and scaled a human down to the size of a bird, our bones are much heavier than a bird's bone. So we have a whole lot extra weight to try to lift off the ground.
Okay. Another good question. Let's see. Who haven't we gone to? Sudbury? Sudbury's been very patient. Is there a question for Dr. Merrett? Okay. I'll just wait. Was there another camp that joined? I have New Hamburg, Sudbury, Dundas, Windsor, Ingersoll, Waterdown, Paris, Goderich. I thought I heard some.
Oh,
Brantford?
yes.
Brantford, welcome. We'll go to you since your mic's on. Did you have a question for Dr. Merrett?
Yes, Lorelai is going to say your question.
What do plane engineers do?
What do plane engineers do? Uh, well, we do quite a bit. So if you just look at an airplane like this, uh, one engineer, his job is to come up with the shape of the fuselage, and that to learn how to do that, to come up with the shape, it takes about 4 years of school. Then another engineer, her job would just be coming up with the engine. So my little toy here doesn't have any engines on it, but an engineer working on the actual engine, she would have to come up with how big is the engine, how much power and thrust can it put out, how much fuel does it drink. And there's a lot of math and science, but also building parts and trying out the parts to make sure they all work. So a plane engineer is quite diverse, and you have to do a lot of hands-on work and spend time working in teams with other engineers to come up with your overall plane.
Wow, a lot of teamwork there.
Yes.
To make something fly. Okay. Let's see. I'm still wondering if Godrich has a question. I don't know if they dropped off or not. Godrich, you can wave at your camera. I don't know if you're having mic problems, if you're with us. It's frozen. Okay. What about Paris?
You guys have another question?
Yes.
Do you have yours? Come closer. You're talking to the mic.
How do wings help a bird fly?
All right, so the question is, how do wings help a bird fly?
Yeah.
All right, so there's 3 parts of a bird's wing that helps it fly. The first is the feathers. In particular, the feathers out near the tips of the wing. You see these feathers the best if you look up a picture of an eagle or a hawk as it's flying through the air. You'll see these feathers. They're almost like fingers being spread out from the tip of the wing. What those feathers do, they help the bird control if it's turning left or turning right. Essentially what the feathers are doing, they're pushing the air around at the wingtip by small amounts, but it's enough to make the bird tip one way or the other. So that's the first thing that the wings do. The second is when the bird has its wings fully stretched out, that helps the bird glide. So it requires the least amount of effort. Birds are lazy. They don't want to use too much energy. So if they stretch their wings out, the whole wing will produce lift and allow the bird to just keep going in a straight line. The third thing that the bird's wings do, it helps them go up and down, so dive or climb. Bird's wings have a joint. It's kind of like our elbow joints. So the bird can pull on its wings. It essentially makes it shorter. Because they're shorter, they produce less lift, and then they can drop into a dive. And if they're climbing, then they start flapping to go up. So that's the 3 items. Control in both turning left and right, also up and down, and to generate enough lift so that the bird can be lazy and just glide around.
Okay. So we're coming to the end of our time, but I think I overlooked Windsor. My apologies, Windsor. Has been very patient as well. Is there a question or two in Windsor? Is Windsor still with us?
Can we ask
Who's
one
that?
more?
Okay. Okay, New Hamburg, yes. Go ahead.
How many years would it take somebody to build an airplane?
All right, this is a really good question. How many years does it take someone to build an airplane? It takes about 20 years. The first 10 years, you actually don't build anything. Those 10 years are spent coming up with the design of the airplane and all of its parts on paper or on a computer and making sure, at least on the computer, that everything works. The next 10 years are when you start building the parts and putting it together into an airplane. Then you have to test the airplane before you can sell it to anyone, because no one's going to buy an airplane if it doesn't work properly. So you test the plane and finally can sell it. So the newest airplane right now is the Boeing 787 and the Airbus A380. They were designed back in 1990. Right now, we're working on the planes that you'll see in about 2035.
Wow. I wouldn't have thought it was, I mean, it makes sense that so much work goes into making an airplane to make it safe and everything, but 20 years.
Yes.
Well, so luckily at STEM camp you're just making a paper airplane, so hopefully you can make that safe to fly in an afternoon. Okay. So because the call quality is not great, I don't know if we had one last question before we end it, but I think our time is coming to an end for today's call. Was there another question in Dundas? Or is that Ingersoll?
Brantford has a question.
Okay, let's do Brantford and then Ingersoll, and then maybe we'll leave it for today for you to go build your airplanes. So Brantford?
How do planes take off and fly in such short time?
So the question is, how do airplanes take off and fly in such short time? So when the airplane gets onto the runway, a normal runway is only about 6,000 feet long. So the airplane produces a lot of thrust. So imagine, again, your car, your parents, there's the accelerator that they probably press. It gives the car some gas to make it go faster. On an airplane, the pilot does the same thing with their engines. They actually push the engines all the way to their maximum power for takeoff. Because the aircraft actually has to be off the runway in about 3,000 feet. The 6,000, the extra 3,000 feet is in case they have to stop the takeoff. So you put on a lot of thrust and just basically push the aircraft off the ground, and you start climbing. Once you're in the air, is when you generate more and more lift, so then you don't have to use the engines as much. But it really is all about thrust and just pushing the aircraft off the ground.
Okay, great. So keep that in mind when you're trying to make your paper airplanes take off, some thrust. So let's go to Ingersoll for the last question today. Ingersoll?
Airplanes don't get hit by lightning during storms.
Could you repeat that a little louder?
How do airplanes don't get hit during storms?
All right, so the question is, how do airplanes not be hit by lightning during storms? Actually, they are. Most airplanes are probably hit by lightning at least twice during their lifetime. But it's actually safe for an airplane to be hit by lightning. You've been warned about if a electrical pole falls on your car, not to touch live wires. The reason why electricity is dangerous on the ground is as soon as you touch an electrical wire, since you're standing on the ground, you've now provided a path for the electricity to go through you into the ground, because that's where electricity usually wants to go. But in an airplane, since we're not touching the ground, when lightning hits the airplane, it actually just goes through and is discharged. Most airplanes along the wings have little rods that stick out, and that's to discharge the electricity back into the sky. And all that happens to the airplane, you have a little paint damage, and that's it. Now, we do try to minimize how many times an airplane is hit by lightning, and what we do, we actually have a map of the world, and it's updated all the time so we can see where the storms are, and airplanes try to avoid flying through the worst of the storms.
So no need to be afraid about flying through a storm. No. That's very reassuring. Good. So Dr. Merrett, I'd like to thank you so much for taking the time to talk to us today about flight.
You're welcome.
On behalf of the entire STEM Camp team, thank you.
And have fun with your airplanes. Playing with paper airplanes, that's what got me into aerospace. So hopefully, maybe this is the start of someone's career there.
Excellent. All right. Thanks again. I guess everyone's on mute. So, Dr. Merrett, you can take yourself off mute. I'll let everybody go.